Hello everyone, welcome to the official walkthrough for MemOps, which is an AI that never forgets an incident, built for VMake devs into Cognee Hackathon. Now let's start with the brutal truth that every software engineer and site reliability engineer knows all too well. Engineering teams lose the exact same wars over and over again. Imagine the scenario. It's Monday morning at 3 a.m. Your pager duty alarm screams. The primary payment gateway is throwing finer to bad gateway spikes. The on call engineer wakes up and frantically grips through Confluence, Slack channels, and Google Drive trying to find the post-mortem from last quarter's outage. They find nothing. The engineer wings it. The resolution takes around 3 hours. 2 months later, another engineer goes through the exact same nightmare. We call this an AI amnesia problem. Every large language model today is fundamentally stateless. It doesn't remember last night's investigation. MemOps fixes that forever. Built on top of Cognee Cloud, MemOps provides engineering teams with a permanent hybrid graph vector memory. Now let's look at the architecture for this first off. So this is the architecture of the whole application. Now, unlike simple wrapper tools that just slap vector rag onto a chatbot, MemOps implements a comprehensive four-layer architecture. So first is our ingestion layer. Uh, MemOps connects directly to the incoming SRE data sources, whether that's automated PagerDuty webhooks, Datadog traces, or Confluence post-mortems, or Markdown runbooks itself. The second is our 8-task custom processing pipeline. When raw text enters MemOps, it doesn't just get sliced into dumb text chunks. Our backend runs an 8-task pipeline. It normalizes the log data, then it uses Gemini Flash, which is our LLM, to extract core entries like microservices and engineers. It timestamps events for time aware queries, and crucially, it validates every entity against an ITIL grounded RDF ontology. This ensures our graph adheres to strict enterprise IT management standards. A third one is our Cognee Cloud, which is the most important part. All four core operations, which is remember, recall, improve, and forget, route directly to the Cognee Cloud, which is this api.cognee.ai. Cognee builds a hybrid index combining a multi-relational graph with fast embed vector embeddings as well. Finally, at the top, we have our conversation layer, which is the Next.js frontend, and we expose 28 REST endpoints, an automated SRE agent decorator, and a 6-tool MCP server that drops right into the cursor, and our stunning Next.js 16 war room, which I'll show in the UI. Now, this was the whole architecture of our like how Cognee powers every feature. We have the core pipeline, and which all features do we use of Cognee? We even use the ontology of Cognee and temporal mode as well. Even we use the provenance as well, like the every graph node links back to the source post-mortem. So this was the whole architecture. Now let's jump straight into the live application which is running here itself. So as you can see, it's on localhost as of now, but we have even deployed the application as you can see here. So this is the UI of our application. Like beyond standard vector database lockup, which has voice copilot and weight tuning feedback as well. It has a unified memory control plane, then ontology grounded incident knowledge graph. So this was the whole landing page. So one of the coolest engineering design decisions is that the offline resilience. When presenting a complex graph database, it often loses context, right? So this is the thing we have focused on here. Now let's see it here. Now as you can see, this is the previous thing that I did. Now this is the 3D war room which is happening in our application. Uh, okay, so first of all, let's go to the telemetry ingest. What happens here is we are passing 6 detailed post-mortems covering everything from cascading Redis cache failures to Kubernetes DNS lookup terminals. Which let's click on this one, which is the SRE outage templates. Let's run this. Now it's running the custom ingestion pipeline and it has been successfully ingested and our graph has been updated. As you can see, 92 graph entities. Now if I click on this, now look at this graph part. Uh, if I click on any of the one, see it's draggable, okay. Now if I click on the red one, okay, which is the Redis cluster split brain. Now what this information says us, it has all the properties of this particular error that we got. So in like less than a second, 6 historical outages have been transformed. If you look into this, it is a live 3D topology using 3JS I used here. So if I'm simulating an active outage, I'm going to click on the, like, let's say this Redis cluster split brain itself. Now, if you look at this, see, you have ontology valid, it's false. What's the version, what's the topological rank, and all of that. We can even summarize this. We even have export graph function as well. As you can see, the incident summary, find out to gateway timeouts lasting 42 minutes. The root cause was isolated to connection pool. So this is the error that we got. We used Gemini AI for summarizing this. We can even prune it from Cognee. It will be removed from Cognee. Root cause was network partition, post-mortem URL also we have, service names, and when was it created and all of that. For each and every error, we will find it. Like infline retries from upstream callers as well, we get the error. So this allows an on-call SRE to visually inspect the blast radius of an outage before touching a single server. So as I shown, only if I hover on it, I can see what error it was getting and what the type of that error was also it tells. So no traditional RAG or flat database can give you this intuitive structural understanding of system topology. So the source node pulses glowing red and downstream dependent services immediately light up in like amber color or yellow color and with directional particles. So as you can see, this legend we have shown here itself, what's the services. So as you can see, it's like a 3D model itself. If I click on this, it will change here. If I click on this, so everything is like happening in real time. We even have the timeline as well, and we can even sync the memory. So it updated in real time. Now we ingested, as I told you. So now let's go to the stateless versus Cognee part. So finally, I'll prove why memory is the ultimate differentiator by running a side-by-side battle right here. So we are submitting the exact same critical SRE prompt to both the models. So we are seeing, let's see what caused the auth service outage. Let's click on compare. Now if you look at this, the prompt that was, it was like we are seeing 502 bad gateway errors on the checkout service after a spike in database. So this is the stateless LLM. It says like you can check your server CPU utilization or inspect load balancer. This is all like shitty stuff. What Cognee does is it has its persistent graph memory analysis. So root cause was connection pool exhaustion, then do not restart cluster replicas. So it gives exact thing that you have to do, and it has current memory as well. So even this is quite important as well. Cognee traversed our graph using the graph completion, which is a part in Cognee. It immediately retrieved incident from 3 months ago, and it this incident which is 882 from 3 months ago, and it tells us that root cause is connection pool. So exact actionable institutional wisdom delivered in like milliseconds itself. We can check with who investigated the last database log as well. So yeah, so this is quite good with Cognee itself, right? So now if I move to the voice copilot itself, issue verbal or typed queries. Now if I type explain failure dependencies for DB service. Now if I like run this,
found mitigation candidate. Save
as you can listen this,
reset of PG
we can even show the
connection
trace
tool.
from where it fetched and all of that. So this engine is graph common. Now if I go on vector search, I can search for vector search as well. Same with natural language, same with summaries. So it's quite useful, right? If you're working in a big company, right? So this was the whole part of this part. Now if I go to AI agent invocation, what this is an autonomous SRE agent invocation. It runs AI agents which is powered by Cognee.agent memory, which is in Cognee docs that I read, which auto injects the historical graph context. Now see, the incident that we got is API gateway find out to across Redis source token rotation. Now if I click on invoke on-call SRE agent, now let's look at this. Let's look at the output. Now see the output. On-call SRE autonomous agent, incident diagnosis, find out to bad gateway that I told. The graph traversal with graph completed, ITIL ontology verification and mitigation runbook match. So it gives a structured agent analysis output as well. Now if I go to post-mortem analysis, and now if I click on invoke post-mortem analysis, let's look at the output. See, it gave the draft PR as well, which is you have to make a PR at this for that particular organization. This is hard coded as of now. Drafted PR this, it automatically drafts the PR as well. So this is also important part. Like it can automatically invoke it using this agent memory and raise a PR for us. Now if we go to the audit console, this is the whole dashboard of our application, like dependency edges, average feedback. We can even find pydantic ontology schema inventory as well. We can inspect, as of now it's empty right now. Now if I go to cognitive refinery, now what this is This uses Cognee's improve pipeline. It consolidates fragmented memory entities and applies engineer feedback. Now, if I click on evolution and growth loads, as you can see in the evolution history, we had completed incident. Just now we did, and graph growth velocity as well. Now, if I run memory evolution, now look at this. The status was completed. Graph optimizations applied are this, and everything is like happening in real time itself. So it's like good for this. Now, the last part is this provenance explorer. What this does is, now if I see any one of the graph node, let's click on this, not this, let's click on this. Sudden surge in query volume. Now, as you can see, it is stored in Cognee Graph. What source content is it? The graph entity, it is a type of incident. So it has a knowledge DNA, like data lineage of the everything that is happening in the application. So yeah, so this was the whole application that I built. It transforms AI from a stateless chat buddy into a permanent brain. So it has like 28 production API endpoints and 6 tool MCP integration. And this MemOps ensures that your team never fights the same fire twice, right? They can like just see this and figure out what's happening. So thank you so much for this whole hackathon. This is the repository of my application. Thank you.